On this machine, we already have installed Python. To check, we type Python 3 -- version. The installed Python version is 3.11.3. If we have a folder for our projects, we can navigate there, which in my case is called PRG. In PRG, we create a new folder, AI Dev, and navigate to the new directory. From AI-dev, we start Visual Studio Code. When Visual Studio Code is loaded, we can go to our plugins and search for a Python plugin from Microsoft. Here, we can open the plugin page and check if it's installed and activated in Visual Studio. We close the plugin page and go to Explorer. In Explorer, we create a file and name it main with extension .py to test if Python is working. We add a simple print function and save the changes. One way to run the file is to click on the Run button, and sure enough, Hello World is printed out. Next, we switch to the terminal. To create a virtual environment, we type Python 3 -m venv and the name we want for our virtual environment. In my case, I name it venv2305. As soon as we create the virtual environment, the folder is created and VSCode suggests it as a virtual environment for the workspace, and it appears in the status bar at the bottom. In the virtual environment folder, you find a subfolder bin and an activate script. To activate the virtual environment, we use source and the path to this activate script. As soon as it is activated, it appears before the command prompt. You can anytime deactivate the virtual environment and choose another one, but here we continue with the one we just created. Make sure you activate the virtual environment before installing packages. Now it's time to install the packages for the project. For this, we create a simple text file called requirements.txt. In requirements.txt, we put a list of all packages we want to install in our project. Here we keep it simple and install just these 4 packages. It's a good practice to upgrade pip before installing the packages. So we type pip install -- upgrade pip. This will upgrade pip to the latest version. After upgrading pip, we can install the packages by typing pip install -r requirements.txt. It will take a little while to install all packages and their dependencies. The packages are installed in the current active virtual environment. Now that the required packages are installed, it's time to generate a new OpenAI key. For this, we navigate to platform.openai.com/accounts/API-keys. Here we create a new secret key. We can give it an optional name and create the key. The key will be shown only once, so be sure to copy the key and close the pop-up. Going back to our project, here we create a .env file. Here we define the variable OpenAI_API_key and paste our key as a value. Going back to main, we don't need this line anymore, and we start from scratch. To start, we import OS. From .env, we import load.env and call it. Next, we create a variable and assign the OpenAI_API_key to it using os.getEnv. Just to be sure, we can print the value of my key, and here we see that the key is loaded successfully. Now we can connect to OpenAI ChatGPT. Here we import OpenAI, then we import LangChain, and from LangChain LLMs we import the OpenAI wrapper. Next, we don't need this line to export the key. Here we use OpenAI for our large language model with a temperature of 0 and pass our key. Next, we pass a very simple text prompt just to check. And finally, we output the answer with a simple print function. It takes a few seconds and we have our answer from ChatGPT. Another way to run the script is using Jupyter Notebook. Here I create a new notebook. The file extension is important and it is .ipynb for interactive Python notebook. Now we copy and paste some code to the first cell and run the cell. It asks for a kernel and we can choose our new virtual environment and the cell gets executed. Next, we create a new cell and transfer more code. To see the value of a variable in Jupyter Notebook, simply write the name of the variable. And we see loading the environment variables works here too. Next, we bring the rest of the code. With Jupyter Notebook inside the VSCode, we can see how long it takes to execute a cell. Here it took 3 seconds. Jupyter Notebook can be run from browser too. Type Jupyter-Lab in the terminal and hit enter. It opens Jupyter-Lab in the browser on localhost port 8888. The same files in our project are listed and we can open our notebook here. We can restart the kernel and clear all outputs. As in Visual Studio Code, we can run the cells one by one and we'll get the same results as we have the temperature set to 0 to be more deterministic. So, AI is a branch of computer science and focus and so on. Going back to Visual Studio Code, we can shut down the server by Ctrl+C. Now it's time to share our project, but we don't want to share all of the files. We create a .gitignore file and list all files and folders which we don't want Git to track and publish. With that said, we make our initial commit. As you can see, the ignored files and folders are grayed out and the changes will not be tracked or published. Finally, we can publish the repo to GitHub. For this repo, I publish it as a public repo. After the repo is published, we can check it on GitHub to be sure the .env file is not published. If by any chance your key is exposed, revoke the key as soon as possible to be on the safe side, as I am doing here. So this was a quick video on set up a local AI dev environment. Setup on Windows and Linux is very similar. If you have any related question, put it in the comments and I will try to answer.